This video is to help people who are stuck on the isotopes questions in GCSE chemistry papers. This builds on a previous video, atomic structure. If you don't understand how to work out how many protons, neutrons and electrons there are in an atom, then you need to go back and watch the atomic structure video. If you cannot do protons, neutrons and electron numbers, then you will not understand isotopes. So make sure you've got that right before you go any further. Okay, so what actually are isotopes? Well, to put it simply, they are atoms with the same number of protons but different number of neutrons. Or to put it another way, they are atoms with the same atomic number but different mass numbers. So, they are going to have exactly the same chemical reactions. That's because they have the same arrangement of electrons around their nucleus, but they're going to have different masses because their extra neutrons will make them heavier generally than the normal type of that element. We normally give them names using their mass number. So for instance, the normal carbon atom that you find on the periodic table, and the type that 99% of all carbon atoms are, is known as carbon 12. So carbon 12 has a total mass of 12. That's because it has 6 protons and 6 neutrons. Carbon 13, on the other hand, is a little bit heavier. Now, because it's carbon, it must still have 6 protons. If it had extra protons, it wouldn't be carbon anymore. But because it's heavier, it has this mass number of 13, then there must be extra neutrons, and in this case it's 6 protons and 7 neutrons, making a carbon 13 atom slightly heavier than a carbon 12. Okay, so here's the simplest example of isotopes you can have. The standard hydrogen atom, which is what the vast majority of them are, is this. It's H11, and that's what you'll find if you look on the periodic table. If you watch the earlier video about how to work out the structure of an atom, you'll be able to work this out yourself. Hydrogen has a single proton and a single electron. If we were being really picky, we'd call it hydrogen 1 because it has a mass number of 1. Okay, now it has a heavier brother. That's hydrogen 2. This is sometimes called deuterium, but for GCSE science, hydrogen 2 will do just fine. If we had this on the periodic table, it would be 1 at the bottom, 2 at the top. You don't find it on the periodic table because at GCSE level the periodic table shows the most common isotope found. Okay, so if we work out what's in here, we have a proton number of 1, so there's the proton. However, we have a mass number of 2, which means we must have 1 neutron to give us that extra mass. So a hydrogen 2 atom is slightly heavier than a hydrogen 1. Well, it's twice as heavy in fact. The electrons are exactly the same, which means hydrogen 2 reacts in the same way as hydrogen 1, it's just slightly heavier. Moving up a step further, we have hydrogen 3. This is known as tritium, but again, hydrogen 3 will do for GCSE. It still only has 1 proton, but it has a mass of 3, which means we must have 2 protons to make up that extra mass. It's important to understand that it has to be the neutrons that are there. It can't be extra protons. If instead of the extra neutron we had an extra proton, this wouldn't be hydrogen 3, it would be helium 3, because what element you're dealing with is determined purely by the number of protons present. Okay, now this is the sort of form of question you often get. They will throw a couple of chemical symbols at you as if they're from a periodic table and then ask you to work out what's in them. So here we have a little table. They've given that to you in the exam. They've given you the information, you need to fill it in. So here it comes. Right, if we were to look at the first one, the chromium 50, we have 24 protons, so that goes in there. The number of electrons is always equal to the number of protons, so that's the same. And the number of neutrons is the difference between the mass and the protons, so in this case 26. The heavier version, chromium 52, must still have 24 protons. Obviously it's got a proton number here of 24, but even if they didn't tell you that, all chromium atoms have 24 protons, and you can tell that by looking at the periodic table. Again, electrons are equal to protons, so 24 of them. but this time we have 28 neutrons. They sometimes follow this question up with one asking you about how a chemical with this isotope would differ from one with the normal version. For instance, if we had chromium oxide made of chromium 50 and chromium 52, what would be the difference? It's very straightforward. Chromium 52 is 2 units heavier per atom, therefore chromium oxide is going to be heavier if it's got chromium 52 than if it's got chromium 50 in it. Occasionally you have to watch out on this question because sometimes they don't ask you for protons, electrons and neutrons, but they ask you for protons, something and mass number. The something could be electrons or neutrons. If they ask you for the mass number, they've given it to you in the question. It's no harder than, in fact if anything, it's easier than asking you for the neutrons. But remember, you have a periodic table in the exam, and that periodic table has a key on it, and on that key it tells you which number is which. I cannot stress enough there is not really an excuse for doing all your isotope questions upside down because you didn't look at the key and you thought that this was the proton number instead of this one.